Welcome back, everyone. Ready to dive into some more cocktail party chemistry.
Always excited to dig into these fascinating science snippets.
Today, we're looking specifically at episode 73.
The chemistry of smog. When air becomes toxic.
Perfect for those cocktail party conversations.
Exactly. We'll be breaking down 5 key factoids about smog.
Starting with how it forms, then we'll look at the ozone paradox.
We'll also uncover the role of VOCs.
And delve into smog's impact on our health.
And finally, we'll explore ways to reduce it. So let's jump right in.
Smog. It's not just smoke and fog mixed together, right?
You'd think so with a name like that, but it's actually way more complex. Smog's like this chemical cocktail, and guess what kicks off the whole brewing process?
I don't know. Chemicals.
Well, yeah, but something has to get those chemicals reacting. And it's sunlight.
Seriously.
Yeah.
So all that beautiful sunshine is actually causing problems.
Well, in a way, yeah. Sunlight provides the energy for reactions between pollutants, like nitrogen oxides.
Which mainly come from cars and industrial stuff.
Right. And then there's those volatile organic compounds.
VOCs, those are in like paints and cleaning products, if I remember correctly.
Exactly. And they're everywhere. So you've got sunlight, nitrogen oxides, VOCs all mixed together.
And that creates ground level ozone, which I guess is a big part of smog.
A major component.
So even if we all switch to electric cars,
We'd still have smog thanks to VOCs.
well, that's a bummer. So choosing low VOC paints really does make a difference then.
Absolutely. Even small choices like that contribute to the big picture of air quality. And that brings us to our next factoid, the ozone paradox.
Okay, so ozone is good up high,
Yeah.
but bad nearby, right?
Exactly. Up in the stratosphere, ozone is like our shield against harmful UV radiation. But down here at ground level, well, it's not so friendly. It becomes a respiratory irritant.
Wow, so location really is everything.
Yeah.
Same molecule, totally opposite effects depending on where it is.
That's chemistry for you. And speaking of chemistry, let's move on to the role of those VOCs. They're like the invisible culprits making air pollution worse.
Right, because VOCs aren't just from big factories or anything.
Nope, they come from everyday stuff. Think about that new furniture smell, or fresh paint drying, even that nice clean scent from cleaning products.
It's kind of scary when you think about it like that.
Well, they all release VOCs, and those react with sunlight.
And that creates more ground-level ozone and other harmful pollutants.
Precisely. Now let's shift gears and talk about the serious consequences of smog, the stuff we don't always see.
Its effects on our health.
Because smog isn't just about hazy skylines. It directly impacts our lungs.
I'll admit, I always thought smog just made my eyes water and my throat scratchy.
Those are definitely some of the immediate effects. But inhaling smog actually irritates the lungs. That can trigger inflammation.
And that's especially bad for people with asthma and bronchitis.
Right. It can really aggravate those conditions. But the long-term effects are even more concerning. Studies have actually linked long-term smog exposure to some pretty serious things.
What kind of things?
Well, heart disease and lung cancer.
Oh, wow. That's way worse than just watery eyes.
And even premature death.
So it's not just an annoyance. This is serious stuff.
Definitely. But we're not just doomed to suffer the consequences. There are things we can do to fight back. One major advancement has been the catalytic converter.
Oh, yeah, those are in our cars, right? Do they really work?
They really do. Catalytic converters basically take harmful emissions from vehicles and turn them into less harmful substances. They've played a huge role in bringing smog levels down over the years.
So it's like a filter for exhaust fumes?
Kind of, but much more sophisticated than that. They use some pretty cool chemistry to convert harmful pollutants into less harmful ones.
That's good to hear. That means we're making progress. But it's probably not enough on its own right. We need to do more.
Oh, absolutely. Reducing smog requires a multi-pronged approach. Think stricter government regulations on industrial emissions, adopting cleaner industrial practices.
And of course, those individual choices we were talking about earlier.
Exactly. Everything plays a part.
It's incredible how this deep dive into smog is revealing all these connections between chemistry, our health, and the choices we make every single day.
It really is interconnected. And speaking of connections, there's another aspect of smog we haven't touched on yet. Its impact on the environment, not just human health.
Okay, so how does smog affect the environment? What kind of damage does it do?
Well, for starters, it can damage plants. That can lead to lower crop yields and even harm forests.
It's like a domino effect. It affects our health and then the health of entire ecosystems.
That's a great way to put it. And the impact of smog doesn't stop there. It can also contribute to acid rain, which acidifies lakes and streams, making them less hospitable to aquatic life.
Wow, this is getting pretty depressing.
It is a sobering reality, but the good news is that we're becoming more aware of the problem and taking steps to mitigate the negative impacts.
That's good to hear. We were talking about the FDA and smog earlier. That connection still seems surprising to me.
It does seem a bit odd at first, but the FDA actually plays a role in regulating certain chemicals that can contribute to smog formation.
Wait, seriously?
Yeah.
I thought the FDA just dealt with food and drugs.
They do, but think about it. Some of the chemicals used in food, drugs, and even cosmetics can release VOCs as they break down. Things like food additives and preservatives.
So our food choices can impact air quality. It's like everything is connected.
Exactly. Even seemingly unrelated areas of our lives can contribute to the smog problem. It just emphasizes the need for a holistic approach to addressing it.
It makes sense, but it's also kind of mind-blowing. All this talk about chemicals and pollution has got me thinking about chemophobia, the fear of chemicals.
Ah, yes, chemophobia. It's a fascinating phenomenon. It often stems from the misconception that anything natural is safe, while anything chemical is dangerous.
Yeah, there's definitely a tendency to automatically view chemicals with suspicion. Like if it's got a long, complicated name, it must be bad for you.
But in reality, everything is made of chemicals, both natural and synthetic. And plenty of naturally occurring substances can be just as harmful, if not more so, than synthetic ones.
That's true. I remember reading about some plants that produce toxins as a defense mechanism. Those toxins are completely natural, but can be really dangerous.
Exactly. The word chemical doesn't automatically mean toxic. Toxicity depends on the specific chemical, the dose, and how we're exposed to it.
So how do we move past chemophobia and make informed decisions about the chemicals in our lives?
Education and critical thinking. We need to understand that chemicals aren't inherently good or bad. It's about evaluating the risks and benefits based on scientific evidence, not on fear-mongering headlines.
That makes a lot of sense. It goes back to what we were talking about earlier. Understanding the science behind things like smog helps us make better choices.
Exactly. Knowledge is power. When we understand the science, we can make informed decisions about our health and the environment without being driven by fear.
This has been such an eye-opening deep dive into the world of smog. It's amazing how something we take for granted, like the air we breathe, can be so complex and have such far-reaching impacts.
It's a reminder that chemistry is happening all around us, all the time. And understanding that chemistry can help us navigate the complexities of our world and make more informed choices.
As serious as all this smog talk is, there's a part of me that finds it kind of fascinating. This invisible chemical reaction happening all around us, creating this hazy blanket. It's like something out of a science fiction movie.
It is quite remarkable, like a secret world operating right in front of us. Speaking of secret worlds, have you ever heard of pyrolytic carbon?
Pyrolytic carbon. Can't say I have. What is it?
It's this crazy material that can actually levitate above magnets.
Whoa, hold on. Levitate,
Wow.
like defying gravity.
Yep. It's because of something called diamagnetism. Certain materials create a magnetic field that opposes an external magnetic field, so they repel magnets. Pyrolytic carbon is super diamagnetic, so it repels magnets with enough force to overcome gravity.
That's wild. It sounds like something straight out of a science fiction novel. What's it used for?
Get this. Artificial heart valves.
Really? Wow, that's incredible. I guess it makes sense, though. It's got to be durable to be used in a heart valve.
Exactly. It's biocompatible and incredibly strong, and its unique properties make it perfect for this application. And speaking of unique properties, have you ever heard of nitinol?
Nitinol. Nope, that's a new one.
Okay, so nitinol is a shape memory alloy.
A shape memory alloy. What does that even mean?
Basically, you can deform it, bend it out of shape, but when you heat it up, it remembers its original shape and springs right back to it.
Wait, are you serious? That's like something out of Terminator 2.
Right. That's exactly what I thought when I first learned about it. But it's real. And it's incredibly useful in all sorts of fields: robotics, medicine, engineering. Think about stents that can be inserted into blood vessels in a tiny, compact form and then expand to their intended shape once they're inside the body.
That's insane. Okay, I need to know more about this shape memory effect. How does that even work? Is it some kind of magic?
Not magic, but it might as well be. It all comes down to how the atoms are arranged within the alloy. When you deform nitinol, you're basically forcing its atoms into a new arrangement. But when you heat it up, those atoms gain enough energy to wiggle around and rearrange themselves back into their original, more stable configuration.
So it's like the alloy has a built-in reset button.
Exactly. And that reset button has led to some incredible applications. For instance, nitinol is also used in those bendable eyeglass frames that always spring back to their original shape.
You mean those frames that you can practically tie in a knot and they just bounce back?
That's the one.
It's amazing how understanding the behavior of atoms can lead to such innovative applications.
It really is. And it highlights that chemistry isn't just about beakers and test tubes. It's about understanding the fundamental building blocks of matter and how they interact to shape the world around us.
That's such a cool way to think about it. Okay, before we wrap things up, I have one more question. We've talked about how smog forms and its effects, but I'm curious about how it's measured. How do scientists actually determine how much smog is in the air?
Good question. They use special instruments called air quality monitors.
Okay, and what do those do?
They measure the concentration of various pollutants in the air, like ground-level ozone, particulate matter, and nitrogen oxides. Basically, they give us real-time data on air quality.
So when we see those air quality index numbers reported, that's where that data comes from.
Exactly. And that data helps us track air quality trends, make decisions about public health, and protect the environment.
It's incredible how technology allows us to measure something as invisible as air pollution.
Yeah,
It makes the problem seem more tangible and maybe even a little less daunting.
I agree. It's a reminder that we can use science and technology to understand and address complex environmental challenges.
This deep dive into smog has been incredibly eye-opening. I've learned so much about the chemistry behind it, the health and environmental impacts, and the ways we can combat it.
It's been a pleasure exploring all this with you. It's a reminder that even though smog can feel like this overwhelming, unstoppable force, we're not powerless against it.
Yeah, understanding the science and taking action can make a real difference.
Exactly. We can create a future with cleaner air and a healthier planet. Talking about how those food additives can contribute to smog, it reminds me of how public perception can really influence scientific understanding, like with food coloring, for example.
You're thinking about red dino too, right? The one they banned.
Exactly. It wasn't actually proven to be harmful, but the public outcry was huge, I think partly because it looked similar to another chemical that was actually dangerous.
So it's more about appearances than actual evidence.
It really highlights how important it is to think critically and to rely on solid evidence, not just first impressions, even when we're talking about something as seemingly simple as food coloring. Which, speaking of things that might appear dangerous but are actually pretty fascinating, have you ever heard of Lichtenberg figures?
Lichtenberg figures.
Hmm.
Aren't those the patterns that lightning leaves behind?
You got it. Those intricate fractal-like patterns. They form when an electrical discharge like lightning passes through a material. You've probably seen pictures of them, almost like tattoos left by the lightning.
I have. They're so cool. It's amazing how something as powerful as lightning can create such delicate, intricate patterns.
It's a good reminder that nature is full of surprises. Even forces that seem destructive can leave behind something beautiful.
Okay, so we've talked about smog, its effects, and even gone off on some tangents about chemophobia and lightning patterns. But before we wrap up, I have a question. We've focused on the negative side of smog, but has all this research led to anything positive? Any interesting discoveries or technological advancements?
That's a great question. And yes, actually, trying to combat smog has led to some pretty significant breakthroughs. Take catalytic converters, for example.
So the tech that helps clean up car emissions has actually helped advance other fields too.
Exactly. Developing those efficient and durable catalytic converters required a lot of research into materials science and chemical engineering.
So the knowledge gained from solving one problem can be applied to other areas as well.
Absolutely. It's like a ripple effect. Solving one scientific problem often leads to benefits in other, sometimes unexpected areas.
That's really cool. It's encouraging to know that all the effort put into fighting smog hasn't just been about damage control. It's actually led to some real progress in other fields.
Absolutely. And who knows what other breakthroughs are waiting to be discovered as we continue to tackle environmental challenges like smog. It's a reminder that human ingenuity and scientific exploration often go hand in hand.
Well said. This deep dive into smog has been a real eye-opener for me. I've learned so much about the chemistry, the impacts, and the things we can do to address it. And I love how we've been able to connect it to other cool scientific concepts.
It's been great exploring this topic with you. It shows how interconnected science really is. Understanding one area can illuminate so much more.
Couldn't agree more. And to our listeners out there, remember, knowledge is power. The more we understand about the world around us, the better equipped we are to make informed choices and work towards a healthier, more sustainable future.
Well said. We'll be back after a short break to wrap up our deep dive into smog with some final thoughts and takeaways.
Welcome back to our deep dive into smog. We've talked about the chemistry behind it, how it forms, and what it does to our health and the environment. We even got into some pretty cool side topics.
Right. Chemophobia, Lichtenberg figures. It's amazing where a deep dive can lead you.
Before we wrap things up, I want to go back to those individual actions we can take to fight smog. What can our listeners actually do to make a difference?
Great question. It's easy to feel overwhelmed by the scale of the problem, but even small changes can make a difference when we all do them.
So it's not just about governments and big industries making changes. We all have a part to play.
Absolutely. Things like choosing to walk, bike, or take public transportation instead of driving.
Okay, less driving. Got it. Anything else?
Well, when you do need to drive, make sure your car's well maintained, like keeping your tires inflated properly. That can help with fuel efficiency, which means fewer emissions.
I'm guilty of letting my tire pressure get low sometimes. I'll have to work on that.
We all do. It's easy to forget. And speaking of everyday choices, opting for low VOC products makes a big difference.
Paints, cleaning products, you said even personal care products?
Right. Those VOCs can really add up. So being mindful of the products we buy, that's another step. But what about the bigger picture?
Yeah, is there anything we can do to push for change on a larger scale?
Absolutely. Supporting policies that promote things like sustainable transportation, clean energy, stricter emissions standards. That's huge.
Okay, so contact our elected officials, vote for pro-environment candidates.
Right. And get involved in community initiatives focused on air quality. There's power in numbers.
So it sounds like there are a lot of ways to contribute to cleaner air, from small everyday choices to pushing for bigger systemic changes.
Exactly. Every little bit helps. And those small actions can inspire others to do the same, creating a ripple effect.
It's kind of hopeful when you think about it that way.
It is. We can make a difference. We can create a healthier world for ourselves and future generations.
This deep dive has been so insightful. I think it really embodies what the deep dive is all about. Taking a topic, really digging into it, uncovering those surprising connections, and most importantly, giving our listeners knowledge that they can use.
I couldn't agree more. It's been a pleasure exploring smog with you and our listeners. Remember, knowledge is power. And understanding the science behind issues like smog helps us make informed choices, take effective action.
Well said. Thanks for joining us on this deep dive into the chemistry of smog. Until next time, keep those cocktail party conversations flowing with fascinating science.